This is SpaceTime Series 21, Episode 48. Coming up on SpaceTime. A massive dust storm on Mars brings a halt to scientific research. Cosmic dust grains older than the solar system. And the discovery of what looks like 6 more Milky Way galactic collisions. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
One of the thickest dust storms ever observed on Mars has been spreading over the face of the red planet, forcing NASA to suspend science operations of its Mars Opportunity rover. However, that same swirling dust storm is opening a new window for scientific research before other spacecraft to learn more about the event. NASA has 3 operational orbiters currently circling the red planet, each equipped with special cameras and other atmospheric instruments. And the agency's Mars Curiosity rover on the surface of the red planet has also begun to see an increase in dust at its location in Gal Crater. Jim Watson, the director of NASA's Mars Exploration Program, describes it all as an historic ideal storm for science. Each probe offers a unique look at how dust storms form and behave on the red planet, knowledge that will be essential for future robotic and human missions. Of course, dust storms are a frequent feature on Mars, occurring in all seasons. Occasionally they balloon out into regional storms in just a matter of days, and sometimes they even expand until they envelop the entire planet. These massive planet-scaled storms are estimated to happen about once every 3 or 4 Mars years, equivalent to about 6 to 8 Earth years. The last was in 2007, and the storms can last for weeks, even months. The current storm, raging above Opportunity, is still growing, now blanketing about 35 million square kilometres of the Martian surface, and that's about a quarter of the planet. All dust events, regardless of size, help shape the Martian surface. The chief scientist for the Mars Program Office, Richard Zurich, from NASA's Jet Propulsion Laboratory in Pasadena, California, says studying these storms is crucial to understanding both the ancient and modern Martian climate. Each observation of these big storms brings science a bit closer to being able to model these events, and maybe someday being able to forecast them. Zurich says that would be a bit like forecasting El Nino events here on Earth, or the severity of upcoming hurricane seasons. Mind you, the thin Martian atmosphere makes these storms vastly different to anything encountered on Earth. Despite what was portrayed in the movie The Martian, atmospheric pressure on Mars is so low that even the most powerful surface winds encountered on the red planet wouldn't be enough to topple over a spacecraft. As is often the case, members of NASA's spacecraft family at Mars often help each other out. The agency's orbiters regularly relay data from NASA's rovers back to Earth. Orbiters and rovers also offer different perspectives on the Martian terrain, allowing their science to complement each other. The Mars Reconnaissance Orbiter has a special role, acting as an early warning system for weather events such as this storm. In fact, it was the orbiter's wide-angle camera which offered the Opportunity team a heads-up about the storm. Just as weather satellites monitor cyclones and hurricanes on Earth, the imager aboard MRO, that's the Mars Reconnaissance Orbiter, created daily global maps of the planet, tracking how the dust storm is evolving. NASA's 2 other orbiters, Mars Odyssey and MAVEN, the Mars Atmosphere and Volatile Evolution spacecraft, also provide unique science views. Odyssey has an infrared camera which can measure the amount of dust below it, and MAVEN's designed to study the behaviour of the upper atmosphere and the loss of gas into space. Of course, science happens on the ground as well, and despite being on the other side of the planet from the evolving dust storm, NASA's Curiosity rover is beginning to detect increased tau. Tau is a measure of the veil of dust haze that blocks out sunlight during a storm. The tau inside Gal Crater is now varying between 1.0 and 2.0, figures that are pretty average for a dust season, although these levels usually show up a bit later in the season than now. Fortunately, Curiosity uses a nuclear-powered battery, so it doesn't face the same sort of risk as the solar-powered Opportunity. Not only is the dust blotting out a lot of the sunlight needed to power Opportunity solar panels, but when the winds die down, there's also the risk that all that dust will settle on the solar panels. Since 2007, scientists have been patiently waiting for the next planet-encircling dust event on Mars, less precisely known as a global dust storm. Although technically the storms never really truly cover the entire globe of Mars. Mind you, back in 1971, one of these storms came awfully close, leaving just the very peaks of Mars' fastest volcanoes poking out above the dust clouds. This new dust storm's interesting. It's the earliest ever detected in the northern Martian hemisphere. It'll take several more days before anyone can tell whether the storm's encircling the entire planet. And if it does go global, the storm will offer a brand new look at Martian weather. You're listening to SpaceTime. I'm Stuart Gary. Scientists have found what appear to be interplanetary dust particles, which predate the birth of the solar system some 4.6 billion years ago. A report in the Proceedings of the National Academy of Sciences claims the discovery opens a new window in understanding the processes which led to the solar system's formation. The study's lead author, Hope Ishii from the University of Hawaii, says the observations suggest that these exotic grains represent surviving pre-solar interstellar dust that form the very building blocks of planets and stars. Ishii says if these grains are in fact the starting materials of planetary formation, then it could be possible to gain a deeper understanding of the processes that formed and have since altered them. The Sun and its surrounding family of planets, moons, comets, asteroids and meteoroids were all created out of the gravitational collapse of a molecular gas and dust cloud triggered by shock waves from the explosive death of a nearby star in a supernova. The early proto-Sun, probably one of hundreds of siblings, was surrounded by this rotating cloud of molecular gas and dust, condensing into initial solids consisting almost entirely of amorphous silicates, carbon and ices. This dust was mostly destroyed and reworked by the processes which led to the formation of the planets. It's thought surviving samples of this pre-solar dust are most likely to be preserved inside comets formed in the outer solar nebula, or in carbonaceous chondrite asteroids containing CAIs, or calcium-aluminum-rich inclusions, which were thought to be the first substances to condense out of the protoplanetary disk which formed the Sun and Solar System. A relatively obscure class of interplanetary dust particles believed to have originated from comets contain tiny glassy grains called glass embedded with metal and sulfides, or gems for short. Gems are typically only tens to hundreds of nanometers in diameter, less than 1/100th the thickness of a human hair. The authors used transmission electron microscopy to examine the composition distributions of these glassy grains, finding they're composed of subgrains which aggregated together in a different environment prior to the formation of the comet parent body. And this aggregate is encapsulated by carbon of a different type than the carbon forming the matrix gluing together gems and other components of cometary dust. The types of carbon that rims the subgrains and that forms the matrix in these particles decomposes with even weak heating, suggesting that the gems could not have formed in the hotter inner solar nebula, and instead must have formed in a cold radiation-rich environment such as the outer solar nebula or the pre-solar molecular gas and dust cloud. I'm Stuart Gary. This is SpaceTime. Astronomers have discovered evidence of a series of at least 6 galactic collisions involving the Milky Way. These intergalactic crashes were revealed in relics of the merger events in the Milky Way's galactic halo. The findings, reported in the astrophysical journal Letters, show 5 small groups of stars which appear to represent mergers with several smaller galaxies. But there's also a really big blob comprising hundreds of stars, which appears to be the remnant of a much larger merger event. The findings are all based on the recent second data release from the European Space Agency's Gaia spacecraft. The Gaia data provides incredibly accurate information on the position and movement of millions of stars, mostly in the Milky Way. The study's lead author, Helmer Koppelman from the University of Groningen, says the data confirms hypotheses that galaxies grow by merging. One of the questions Koppelman wanted to answer was whether a lot of small galaxies merge or just a few large ones. To try and resolve the issue, the authors examined Gaia data on stars in the Milky Way's galactic halo, the spherical cloud of stars surrounding the galaxy's main disk and central bulge. You see, it's long been hypothesized that these stars could be remnants of past merger events. Koppelman and colleagues collected Gaia information from stars within 3,000 light-years of the Sun. As the closer the stars are, the more accurate the data about their position and movements will be. The first step was to filter out all the stars in the foreground from the Milky Way disk. These stars move around the center of the galaxy, so they're fairly easily identified. What then remained was something like around 6,000 halo stars. By calculating their movements across the sky, Koppelman and colleagues were able to identify stars with a shared origin. They found 5 small clusters of stars, each of which appeared to be remnants from one of 5 separate merger events. However, they also noticed that the remaining stars also appeared to have a shared history. These stars were forming a huge blob in retrograde or backwards movement compared to other stars in the galactic disk, and that suggests that they're the result of a merger with a large galaxy, which may even have remodeled the disk of the Milky Way itself. A more detailed study of the nature of this merger is now underway. Meanwhile, Koppelman also looked for stars belonging to the Helmy stream, which is named after his PhD supervisor, who identified it back in 1999 as the remnant of a merger event. Previously, fewer than 20 stars were identified as belonging to the Helmy stream. However, the Gaia data has now added over 100 new stars to the stream. Further analysis should clarify the nature of the galaxy that produced this stream. Of course, there are numerous other streams of stars within our galaxy, moving in slightly different directions or at slightly different velocities, which have already been identified over the years. A stellar stream from the Sagittarius dwarf galaxy, which is currently being cannibalized by the Milky Way, is a good example. And there are stellar tidal streams of stars and gas from two other satellite galaxies, the Large and Small Magellanic Clouds, which are also flowing into the Milky Way. Meanwhile, in about 3.7 billion years from now, the Milky Way itself will be ripped apart, forming its own stellar stream as it collides with the much more massive Andromeda galaxy M31. You're listening to SpaceTime. I'm Stuart Gary. The Australian federal government's introducing new legislation designed to make it easier to launch spacecraft from Australian soil. The new regulations are part of a major shake-up of Australia's stagnant space industry, which long ago lost the glory it held during the 1960s and early 70s when Australia became only the fourth nation on Earth to build a satellite and have it launched into orbit from its own soil. Innovations Minister Senator Michaela Cash says the new rules will relieve the antiquated decades-old regulations stifling Australian businesses trying to compete in the $500 million global space market. Australia's current share of that huge market is just 0.8%. The changes come as Canberra sets up the nation's first space agency, which will formally come into effect on July 1st. While Australian industries are building satellites and spacecraft systems, there are no longer any orbital launch operations undertaken from Australian soil. The new regulations will include specific air traffic control safety and engineering requirements for launching high-powered rockets using either ground-based or mid-air launch systems. The new rules will also mandate specific insurance requirements for rocket operations, including launches, orbital operations, and atmospheric re-entries. Senator Cash says the new agency will encourage Australia's space industry to at least triple to about $12 billion by 2030, in the process creating up to 20,000 new jobs. Dr. Brad Tucker from the Australian National University says the new legislation is designed to bring Australia in line with global practice, reducing barriers and red tape to encourage more private investment in the domestic space industry.
So this is a kind of a revision of what we call the Space Activities Act. So there is the original, depends on how old you want to go, but one of the more recent laws was the 1998 Space Activities Act, which said this is how someone launches and does stuff from space. Now, 1998, being 20 years ago, a lot has changed since then. And so in the past 3 years, there's been a specialist group and committee setting aside to update the laws to bring it in more in line with what's needed today and hopefully into the future. And so this is called the Space Activities Amendment Bill of 2018, with a focus on what's called launches and returns. And now that is about to go before the House and Senate for approval.
So this makes it easier for companies like Gilmore, for example, who are about to start a series of suborbital and then eventually, hopefully by the end of this year, orbital flight tests to actually do what they need to do.
Yeah, so there's like a couple key points that are quite interesting in this. One is that it helps set up the framework for launching from an aircraft in flight. Now, that might seem a very technical thing, but it's exactly what you said. There's groups in Australia that want to do suborbital launches. They put a rocket into suborbital, still on the Earth, not quite into orbit, and then launch a satellite from there, because it means that kind of like a space plane goes up and comes down, and then you launch a satellite from
Galactic to do, for example.
Exactly. And so if you can launch a satellite from higher, you save on the cost of the entire rocket from Earth. There's no law that really has existed or framework for those before, because 20 years ago that technology wasn't really here. It is now. And then in general, kind of helping the barriers or the hindrances of putting something into space, because you have to have space insurance. Space insurance is a real thing that you have to get as a satellite.
In case you hit someone else's satellite by mistake?
Yeah, exactly.
Fall onto a house when you're re-entering?
That's right. And the problem is, it goes back to why the UN is convening a meeting next week, is that the original space laws are essentially 50 years old, and they're all governed at the international treaty level. And so they're massively out of date with what's happening. So, I try and like to do a thought experiment. So let's say, Stuart, you are company A, and you're launching from Australia. Australia. I'm Rocket Company B, based in the US, but we decide to launch in New Zealand because we need to get into orbit. So your satellite goes onto my rocket and we launch from New Zealand. If your satellite crashes into, let's say a Russian satellite, it's actually New Zealand that is responsible.
Right. Yeah.
If that is confusing and kind of outdated, because it is, it's essentially who puts it up. The country that puts it up is responsible. But because we have private companies doing launches and we have private satellite companies, it doesn't really govern it.
I guess you can complicate that even further if you have a third party who's taking care of the actual orbital management of the satellite.
Exactly. And because it was always countries doing this, and now there's companies and universities, if someone from Australia has to want to do it, there's been a huge amount of paperwork and issues for Australia to essentially back the insurance claim to the rocket company and the country launching it. So part of the Space Act, why it's called Launches and Returns, is to make it easier for groups to go into space and to help really space industry and businesses and startups in Australia get involvement without unnecessary paperwork. So you could imagine that if something goes wrong and your satellite knocks out a $100 million U.S. defense satellite, they're going to come after you, and you necessarily can't afford those damages. And this is actually part of the Space Act and what this new bill that says that not only do we want to make sure that it's easier for people, but it's also making sure people are more responsible. So a lot more checks and testing in order before things are happening. So it's a lot more, checks and balances, not only to make it easier, but to make it sure that people are doing the right thing to make it easier. So facilities like we have here at Mount Stromlo, which is for spacecraft testing, are all the more important because people are going to definitely need it before they get their license approval. And that's why we have the facilities here, so people can do their checks and make sure their satellite's going to do what it does and break, because you also don't want to lose your satellite because you've just spent millions of dollars to build it. So we can have a blossoming industry here in Australia.
That's Dr. Brad Tucker from the Australian National University. And this is Space Time. I'm Stuart Gary. There's been a busy change of crews aboard the International Space Station. Just days after the Expedition 5455 crew returned safely to Earth following their 168-day stay aboard the International Space Station, the Expedition 5657 crew blasted into space for their own 6-month stay aboard the orbiting outpost. The changeover started with the Expedition 5455 crew aboard their Soyuz MS-07 spacecraft touching down under the giant orange and white canopy of their parachute on the remote Kazakhstan steppe. The landing occurred 6 hours and 45 minutes after locking hatches between the orbiting outpost and the Soyuz, and just an hour after the Soyuz crew initiated their deorbit burn 410 kilometers above the planet's surface.
The Soyuz making its way home, still going fast under a drogue chute that will be making way for the 5,575 square foot main parachute. It slows down the Soyuz to about 22 miles per hour and holds it with a couple of harnesses at a 30-degree angle to the horizon until the bottom harness is removed and the Soyuz swings into a vertical position for touchdown.
The crew members are feeling well.
Inside the Soyuz capsule, we have returning astronauts Scott Tingle, Norishika Kanai, and Anton Skraplerov making their way home after 168 days in space. Everything's been going well on their return from the International Space Station, which began with a hatch closure at 12:55 a.m. Central Time this morning, followed by an undocking from the space station at 4:16 a.m., and then a deorbit burn at 6:47. It's making its way down for a touchdown at 7:40 a.m. Central Time in the Kazakhstan deserts southeast of Jezkazgan. When they are about 39 feet above the Earth, the commander of the Soyuz, Anton Skraplerov, will get a notice from the computers to prepare to fire 6 solid propellant engines called the soft landing engines that will slow the Soyuz down to about 5 feet per second or 3.5 miles per hour. The capsule is scheduled to touch down at 7:40 a.m. It's going to be landing southeast of Jezkazgan, Kazakhstan, and a contingent of Roscosmos and NASA personnel are on their way to meet it and be ready to get the 3 crew members inside the capsule out as quickly as possible after touchdown. Soyuz MS-07 officially landed. That brings to an end a 168-day in space for these 3 members of the Expedition 55 crew. NASA's Scott Tingle and the Japan Aerospace Exploration Agency's Norishige Kanai, as well as Roscosmos's Anton Shkaplerov. This was the first flight for both Tingle and Kanai, so they now total 168 days spent in space, while Shkaplerov has now been to space 3 times and spent a total of 532 days there, tying him with the Roscosmos' Mikhail Churin for 17th on the all-time list of days spent in space. With the crew now on the ground, the support team is beginning to arrive and make their way to the landing site. That includes 8 Mi-8 helicopters and carrying an inflatable medical tent that the crew will use after they've gotten out of the capsule. There are also a number of NASA representatives on board the helicopters, including Deputy Space Station Program Manager Dan Hartman, astronaut Shell Lindgren, Flight Sergeant Rainier Effenhauser, NASA Landing Team Coordinator Chad Rowe, and NASA spokesperson Gary Jordan, as well as NASA photographer Bill Ingalls. Also deployed for landing were 6 all-terrain vehicles and 3 airplanes that served as flying command centers. They gave us direct communication with the crew and relayed that communication back to Moscow. As the helicopters arrive, that portable medical tent will be set up near the capsule where the crew will be able to change out of their launch and entry suits. And Russian technicians will open the Soyuz's hatch and help the crew members out, but since they've been living in zero gravity for the past 168 days, they'll be feeling the effects of being back on the Earth's surface, and so will be seated in some special reclining chairs near the capsule for some quick medical tests and phone calls. Then as soon as possible after landing, the crew will be helped into helicopters for flight back to Karaganda, Kazakhstan, where local officials will welcome them at the airport. Then Tingle and Kanai will return to Houston while Shkaplerov goes back to Moscow.
The crew had orbited the Earth some 2,688 times, covering some 115 million kilometres. During their time on station, they took part in some 260 experiments, including material science testing, studying the effects of microgravity on bone marrow, and research into plant growth in orbit. They also undertook several EVAs or extravehicular activities, NASA speak for spacewalks. These were needed to carry out routine maintenance work on the space station's equipment, including the robotic Canadarm2, and replacing an instruments package for the communications antenna on the Russians' Vesta service module. They also helped with the arrival of 4 cargo ships, which delivered tons of supplies, equipment and experiments to the orbiting outpost. These included 2 SpaceX Dragon capsules in December and April, as well as an orbital Cygnus cargo ship in May, and a Russian Progress supply ship in February. The 3 Expedition 55-56 crew members left on station were joined 5 days later by the 3 new Expedition 56-57 crew members. The new crew had flown up aboard their Soyuz MS-9 capsule, which had launched 2 days earlier aboard the 50-metre-tall Soyuz FG rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan.
Soyuz now on internal power in preparation for its flight to the space station.
Everything is nominal on board, ready for launch.
That's the first umbilical tower separating from the booster. Have auto sequence start now. The ground umbilical to the 3rd stage has been disconnected. And there's the 2nd umbilical tower now separating. We're 10 seconds from launch.
Oxygen.
5, 4, 3, 2, 1. See the engines igniting there. And liftoff of Soyuz MS-09 carrying Serena Anand Chancellor, Sergei Prokopyev, and Alexander Gerst to the International Space Station for a 6-month stay to
Everything is nominal.
complete research on board the space station.
20 seconds.
Good
nominal.
help us here on the Earth as well as in space.
For this mission, the Soyuz MS-9 was placed into a 34-orbit 2-day flight path to the space station. The Russian Federal Space Agency at Roscosmos also employs a 4-orbit 6-hour fast rendezvous flight path for Soyuz and Progress, depending on the space station's altitude. But this requires the Soyuz to launch shortly after the space station passes overhead, and then undertake a series of additional long orbital maneuvers, firing the capsule's thrusters earlier in its mission in order to reach the space station's orbital altitude and velocity. Roscosmos have also been experimenting with an even faster 3-hour 2-orbit fast-track rendezvous, which has so far only been tested by Progress. During the next 6 months, the new crew will study ultra-cold quantum gases, undertake commercial microgravity research, use surface forces to carry out the separation of liquids in space, undertake new tests to see how muscles and the brain react to stimuli in space, experiment with new hands-free aids for astronauts, and see how metal alloys form in microgravity. You're listening to SpaceTime. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study by NASA and the European Space Agency has revealed that Antarctica has lost around 3 trillion tons of ice since 1992, and that's an amount which has corresponded to a sea level rise of around 8 millimeters. The findings, reported in the journal Nature, are based on 24 different satellite studies. They show that warm oceans have driven a tripling of ice loss in western Antarctica between 1992 and 2017, from 53 billion to 159 billion tons per year. Meanwhile, a separate study has confirmed that ice loss on the Antarctic Peninsula has also increased, from about 7 billion to 33 billion tons per year. Storm-driven ocean swells have triggered the catastrophic disintegration of the Antarctic ice shelves in recent decades. Researchers say that reduced sea ice coverage since the late 1980s led to increased exposure of the ice shelves on the Antarctic Peninsula to ocean swells, causing them to flex and break off. A new study has confirmed that loneliness really is bad for the heart and a strong predictor of premature death. The findings, presented to the European Society of Cardiology's annual Nursing Congress, also revealed that feelings of loneliness were a far stronger predictor of poor outcomes than simply living alone. Previous research had already found that social isolation and loneliness are linked with coronary heart disease and stroke, but this had not been investigated in patients with different types of cardiovascular disease. The new study investigated whether poor social networks were associated with worse outcomes in 13,463 patients who had ischemic heart disease, arrhythmia, heart failure, or heart valve disease. Data from national registries were linked with details on patients' physical and mental health, as well as lifestyle factors such as smoking and social support. Feeling lonely was associated with poorer outcomes in all patients, regardless of their type of heart disease. And even after adjusting for age, level of education, other diseases, body mass index, smoking, and alcohol intake. In fact, loneliness was associated with basically a doubling of mortality risk in women and a nearly doubling of risk in men. In fact, both men and women who felt lonely were also 3 times more likely to report symptoms of anxiety and depression and had a significantly lower quality of life than those who did not feel lonely. A new study claims that large crocodiles in the Alligator Rivers region of Australia's Northern Territory do much of their dining not within their river systems or estuaries, but on feral pigs and other land animals visiting the waterways. The findings, reported in the journal PLOS One, forms part of a larger study of river and floodplain food webs led by Griffith University. The estuarine or saltwater crocodiles are the apex predators in these systems, eating a broad variety of freshwater and marine animals. However, researchers were surprised to see how many feral pigs form part of the saltwater crocodile's diet. About 50 salties were tested over a 2-year period, 75% of whom were more than 2.5 metres in length. Estuarine or saltwater crocodiles commonly grow to over 6 metres or 18 feet in length, with larger specimens reportedly reaching up to 10 metres, that's 30 feet. Using a "you are what you eat" philosophy, scientists use chemical traces in crocodile muscle tissue to distinguish between the different major prey groups, from terrestrial, freshwater and marine environments, finding most of the large crocodiles had a distinctive terrestrial prey signature and were most similar to that of feral pigs. Now, speaking of fine dining, a new study is looking at why we love fries with that. The study claims people find foods that combine fat with carbs more rewarding than either alone because they hijack the brain, leading to an overestimation of the energetic value of the combination. The findings, reported in the Journal of Cell Metabolism, are based on scans of people's brains as they chowed down on fatty snacks, on sugary snacks, and on snacks that combined fat and carbs. Then, when asked to bid on different snacks, researchers found people were willing to cough up more cash for fatty carbohydrate snacks, which also lit up reward centers in their brains far more than their favourite foods, sweeter foods, or more energy-dense foods. How the brain reacts to the combination of fat and carbs could help explain how the obesity epidemic took hold, although it still doesn't explain the Scottish delicacy of deep-fried Mars bars. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.